Well, thank you everyone for joining me today. My name is Hannah Valentine. I'm with the American Institute of Steel Construction, or AISC. My role at AISC is a structural steel specialist. So I am a structural engineer by training and experience. And about a year or so ago, I switched over to working with AISC, utilizing my experience in steel design on different project typologies from stadiums to more commercial to help connect the steel industry with folks out here in Southern California. So you probably have heard about AISC at some point. If you took any sort of architecture class and you have a manual somewhere that you maybe bought, but AISC is an organization that has been around for over 100 years. We're a nonprofit. And in addition to our design guidance, we also do a lot in the space of design workshops and design competitions, as well as support continuing education efforts such as this. So if you ever have any questions about structural steel, AISC and myself are always a good place to start. So today we'll be talking about structural steel and sustainability, and really getting a primer for the sustainable properties of structural steel. So this is an introduction to sustainability and structural steel. As such, this is an AIA accredited presentation. So anyone listening in live now will be getting AIA credits for this, either one LU or one HSW, pending what you need. And also is copyrighted. So just a quick kind of hit on the course description. We're really going to talk about the parameters for choosing a structural system or a structural material outside of the typical decision makers like efficiency and cost. And so we'll go into that in a little more detail today. This will include hitting the 4 learning objectives, describing the structural steel supply chain domestically, understanding the circular life cycle of structural steel and how it plays into the sustainability properties. See the structural steel industry's commitment to providing environmental product declarations, and learn a little bit more about what exists out there information-wise and other AISC resources. What that really boils down to is we're going to spend some time in these 4 buckets. We're going to talk a little bit about the steel supply chain in the US, talk about some myths and facts that people might have about structural steel, talk about steel environmental product declarations and sustainability commitments from the steel industry, and then finally, what you can do as a designer when making your steel building more sustainable. So we will spend some time today talking quite a bit about the structural steel supply chain, and that is because it's really foundational to understanding structural steel and its sustainability properties, because steel is recyclable. You really need to understand what that means in terms of why steel is sustainable. Each material and each structural property is different and has its place. And in this instance, steel is the recyclable property. You might think about concrete as maybe more local, and then a renewable with wood. So we'll walk through a couple of players starting out in the steel supply chain, because often even engineers don't know who all of these folks are. Starting with the structural steel mills, this is where your steel beams that you're getting on your steel projects, your channels, any kind of steel product is getting made. On the screen right now are all the steel mills the major steel mills that produce structural wide flange beams, so hot rolled sections. That's Nucor, Gerdau, and Steel Dynamics. You can see I'm giving this presentation into Southern California, from Southern California, that we don't have any steel mills until Texas and east of Texas. And so a lot of times the next question kind of goes, well, where is California really getting our structural steel? And the answer is steel service centers. So steel service centers function essentially like Costco's for structural steel. So they'll do a big order of a structural steel section, and then they'll keep it in stock for people to buy, to have it more accessible. and to not have to purchase a large steel mill order. So oftentimes, if your project isn't too large, you're going to be getting your steel from a local service center. We have a couple near us, including CCC Steel and Brown Strauss Steel. And the person typically purchasing the steel from the service center or steel mill is the steel fabricator. And so AISC has 1,600 certified steel fabricators. We certify fabricators, basically providing a QA, QC kind of quality assurance stamp of approval from AISC. They're audited every year, and or their facility is audited every year, I should say, to maintain their certification. And in addition, one step above that are various endorsements. Some that folks might be looking for often here are perhaps complex coding endorsements or seismic endorsements. And a lot of times the engineer will be making the assessment of if they need that or not. In addition to steel fabricators, there's also membership. So just like they're professional members of the American Institute of Steel Construction, there's also fabricator members, and they join for similar reasons to the professional members to essentially receive membership benefits. So we've gone from so we've kind of hit the major players in the steel supply chain. So we'll talk a little bit more now about how steel is made in the US. So you can see on the screen right now, we have an EAF or electric arc furnace mill. EAF is a type of steel production that uses electricity, and it has about 75% less embodied carbon than the traditional BOF production. So all wide flange sections that you use in your buildings are sorry, I got distracted by the chat. All the wide flint sections used in your buildings are coming from an EAF for mill if they are produced in the US. And then if you're using a tube section, so if you have any sort of HSS, round or rectangular tube, that's actually produced from steel coils. So it's a slightly different method than what we'll be talking about today. And so those mills are at about a 60-40 split of EAF production. So 60% EAF, 40% BOF, and it's trending more towards EAF as we continue on and as the industry makes more commitments to sustainability and invests in their future mills. If you only remember one number from this presentation, this is the number to remember. When a new steel mill member arrives at your job site, 93% of that material already existed in a prior life. It was cars, refrigerators, demolished bridges, scrap, etc. All of that gets put into a big heap like you see behind me and is 100% recyclable. So basically all the steel that you've been recycling becomes, if it's not a steel member, it's becoming a steel product. So all steel gets recycled at end of life. So this is kind of an overview of the steel supply chain we'll be speaking about a little bit more today. We'll start with scrap collection, talk a bit about scrap processing, move on to what happens in the structural steel mill, steel fabrication, construction, erection, progress, and building operation to deconstruction. And starting with scrap collection, I think it's important to note that if domestic steel basically does not use any raw material iron ore, so when you use 1 ton of steel that's recovered, 1.1 tons of iron ore is essentially saved. What this really boils down to as a number is that the recycling of steel from automobiles just alone, and we'll see what that number is in a minute, saves the energy necessary to power 18 million homes every year. So it's a pretty significant figure when we're talking about this. And you can see on this slide that about 93% of all automobiles are recycled at the end of life, as well as 98% of all structural steel is recycled at the end of life. So we're at a pretty good rate for steel recovery overall. Kind of the major components that get recycled into structural steel are on the screen here, and overall about 88% of them are recovered. The other thing to note is that it's great that we're recycling or we're collecting scrap and recycling it, but where is it coming from? What's kind of that process? And the answer is that all the scrap that's feeding into the mills that we just looked at are coming from about within 400 miles of the mill. So, and the majority of them get there by rail or barge. Um, Scrap processing, I'll just hit on this really quickly. So once the scrap, there's either a remote scrap facility or there's an area at the steel mill where scrap is processed. So it gets kind of broken down and sorted so that can be fed into the EAF process. A quick note here about metallurgy. You'll note in my introduction, I did not include metallurgists. But AISC as an organization does hire and work with metallurgists about structural steel. Overall, though, structural steels are about 97 to 98% iron and have a relatively low carbon content, which is responsible for the toughness and weldability properties of structural steel. The other thing to note here is a lot of the other components other elements, I should say, that go into structural steel are a relatively low, amount. And so that really just changes depending on what recipe of structural steel you need, if you need A992 steel or something else. So we've talked a little bit about scrap selection. Once the scrap is selected and processed, it goes into the electric arc furnace. It's heated to about 3,000 degrees Fahrenheit. And during that process, there's a foamy byproduct that raises to the top called slag. And so that slag basically gets collected and then sold and used. So it's sold and used in like roadbeds, for example. It doesn't end up, kind of going as waste. They end up kind of profiting, making money off of the byproduct. Now you have the metallurgical mixture left. Once the slag is gone, it goes into ladle refining. That's where we're adding some of the metallurgical components, small amounts that I showed on the previous slide. So that's where they'll use a mass spectrometer to basically measure, how much each kind of material is in there and once everything is kind of fit to that recipe. Once we're at that point, that mixture is poured into a steel beam blank, and then it's heated and recooled, basically continuously cast until it's in the shape of the wide flange beam that you're trying to make. And then at the end of that process, which is about 3 hours, you're at your finished product. So a little bit to kind of note about some of the things I just talked about. The water is at a recycling rate of about 95%, so they capture most of the water that's used to heat and recool. And then a couple of things to note about kind of where we have been since about 1990 to where we are today. Since 1990, steel's carbon footprint has reduced almost 50%. And most of that, if not all of it, is due to the switch to EAF production of wide flange beams. Productivity, labor hours also has decreased significantly from 12 to 0.6 hours per ton. And a lot of that's due to automation of various processes. And the final thing to note is the amount of steel we use, or the material weight, has gone down significantly because steel strength has increased by 40% since 1990. So the 50 KSI, if you've from the structural engineer might use, that switch has happened since 1990, and we're basically getting more bang for your buck with the strength when that's getting specified. I'll leave this up for a moment and we can come back to this slide just for folks to get. I don't normally leave time for this presentation, but there is a virtual mill tour on YouTube from the mill Nucor that I would encourage you to go if you're looking to understand and visualize some of the processes I just spoke about in more detail. So we've gone through the process, it's gone through the mill, the 3 hours through the EAF production process to become a steel beam. Once we're there, it's a distribution phase. So a lot of mills will have a rail yard near their facility to essentially go directly from the steel mill to the rail. And that's why about 54% of all steel is distributed by rail. The rest of that's basically truck. You know, you can't get everywhere with rail, so eventually you're using 34% of a truck to move it from place to place. So we did talk about service centers a little bit at the beginning of this, and I just want to hit on that, that the majority of steel that we're using in the US is being provided by steel service centers. We're not getting them directly from mills. So about 70% of all structural steel is coming from your steel Costco. So that means that that's good for designers, because that means that in as little as 1 to 2 days, if you have something come up on site or you need a section, the availability is there. The supply chain is robust enough to essentially know if you need a section, it's going to be available, as long as it's fairly typical or common. So steel fabrication is where we've finally got the fabricator will buy the structural steel and then basically make it the beam that goes in your beam or column or steel member or piece that goes in your building. So that's where all of the welding, drilling, beams get cut to length. So basically, take a steel shop drawing and make it reality, and that's what's happening in the steel at the steel fabricator. Because this is essentially prefabrication in a sense, there's relatively little waste, and any scrap that they have is able to be sold back into the steel supply chain. Basically, we're at about 7.7% waste with this process, but there's a couple of things that have been happening in steel fabrication that will make that number even less. One of them is utilizing 3D modeling more. So I think we are all pretty familiar as designers with BIM as a process. No one would claim that as cutting edge as it stands, but it is in the use for steel fabrication in some regards. So you can take a model or even produce a model based off of drawings and basically program a steel beam to be cut, to be drilled, and then have pieces welded and basically be picked up by a machine and welded exactly where it needs to be. And that repetition, if you have beams that are the same, makes that even faster. So that's what we're seeing now, is the embracing of steel automation in fabrication, and other kind of, you know, utilization of technology. Which really, the one thing that I didn't hit on is that it does lead to a reduction of errors. So you're not necessarily having to deal with as many issues because of the automation happening on the fabricator's end. So on your end, you're not seeing as many issues. So relatively speaking, because all this work is happening at the steel fabricator and not necessarily on site, you're going to get a faster erection procedure, a faster erection schedule than you would perhaps with another material. So we've gone through kind of almost all the stages of a building, right? Where we've seen it erected and then kind of become the building that it is today. And then it's perhaps gone through the process where steel has come in and out. We've maybe retrofitted the building a couple of times, maybe added some new steel beams, some new structure in there to facilitate that. And then finally, we're at the end of a building's life where no one's using it anymore and they want to recover the material. That is really just the beginning, because of the way that the steel supply chain works for the steel material. Steel is infinitely recyclable. And then also the owner can basically deconstruct the building at little to no cost, because they can sell the steel back into the supply chain, both to fabricators, or not fabricators, both to the mills, but also to other makers of steel products. So that's one of the kind of benefits of a structural steel building, is that there's an opportunity, if you don't reuse a beam or column, to still melt it down and reuse the material again. We are starting to talk about reuse of material in terms of just refabricating a steel beam, instead of, and so just going back to the fabricator shop instead of going back to the steel mill. But there are some because challenge is still with adjusting that supply chain and some growing pains there. So it's not happening, all the time yet. Overall, we're at a 98% recovery rate for structural steel, which I've mentioned previously. A really quick note here, I won't touch on this for long, but the EPA does release kind of data on construction and demolition debris in the US. And there's a couple of things and lessons to note from the data that they've released so far. These numbers are from 2015, but it's been republished. So this is kind of the best we have right now. During construction, because so much of the fabrication happens off-site, there's relatively little waste. Remember, these numbers are in thousands of tons. So in terms of that factor, there's relatively little waste for so negligible they don't have a number. And then when we're looking at demolition, there's a different breakdown between concrete, wood products, and then steel. And so I'll just let you kind of digest those numbers. I think it's interesting to note, just in terms of thinking about waste as another factor in sustainability. This is where I kind of like to pause. I know we've gone through a lot of life cycle and questions or processes. So if there are any questions right now, there'll be an opportunity later. But if there are questions now, I'd love to answer any that popped up.
Hannah, we don't have any in chat, but I suppose we come off mute if they want to.
Sure. Well, I'll keep going and if save them for later then, and we'll get to it and when we get to it. But a couple, we'll still have a breather. This is just myths versus facts about structural steel that kind of reinforce everything that we've just talked about. Some folks think there may not be a steel industry in the US. They're really thinking of China when they think about structural steel. Really, we know as AISC, because our members report numbers to us, that domestic structural steel mill capacity exceeds demand. In 2020, the steel mills produced 6.8 million tons of structural steel. At the latest number that we know they're able to produce is 9 million tons of steel. So there's capacity there in the domestic supply chain if people were to suddenly start building way more steel buildings. The other question that sometimes comes up with this is scrap a limiting factor as well on the supply chain? And the answer is no. The US is exporting scrap right now, so it could also facilitate this. Myth 2, all steel is the same. We know that imported steel has higher environmental impacts due to not relying on the electric arc furnace process. It's about 3 times higher than domestic structural steel. And that's typically we're talking about China, but it's really any steel that goes through the BOF process as opposed to the EAF. The final thing, or second to final thing, iron ore is used to make domestic structural steel. No iron ore is used for domestic structural steel. It's made from recycled scrap. So I won't dwell on these graphs for too long, but there's a couple of interesting kind of trends when you look at the largest steel producing countries and where they're at in terms of sustainability. The first graph here is showing essentially CO2 intensity. So it's tons of CO2 per tons of steel. US, it's about at 1, and and we slowly kind of go up from there. But then you can see with crude oil production that China is leaps and bounds ahead of anyone else on the previous chart. So even just switching away from China a bit would move the needle on some of this. And that just to hone that in, the number that I just talked about with the 6.8 million includes 2.1% of the world market share. EAF production, it's being talked about like it's new, but it's been around basically as long as BOF production, just not as popular. So starting from 2000, you can see we're about 2002, where the inflection point from the popularity of electric arc furnace to basic oxygen furnace production of steel switches, and we're moving further and further upwards with that trend. And then a little bit of a gimme on this slide that, the more recycled content, the less embodied carbon you're going to have. That's why we've been talking about it in depth, and I think it's pretty pretty understandable in terms of the process. So we'll talk a little bit now about EPDs and sustainability commitments from the steel industry. I hope most folks know what EPD stands for, but if you don't, it means Environmental Product Declaration, and is basically the nutritional label for your material, in this case, your structural steel beam. In terms of EPDs in the steel industry, we've been fairly transparent as an industry for a while. We have had industry average EPDs on our website. And all EPDs go through a third party, certifier. So we went through that process to get EPDs for hot rolled sections, steel plates, and hollow structural sections. And in this, these are on about a 5-year cycle. So I think that cycle is up soon-ish. But these are good numbers to use if you are at kind of an early schematic phase of design and you don't know where your steel is coming from. So that's a great resource for designers to know that they exist, and they're very easily to find on our website, because all you have to remember is AISC.org/EPD. The other thing I'll note is that we do have a director of government relations and sustainability. So there are there has been sustainability legislation that has come out. We know of Buy Clean California, and I'll talk about these a little later. But Buy Clean California, and then the pending changes to Cal Green. And AISC does join those meetings and work with organizations such as SC 2050 to provide input on the steel industry and kind of help provide any resources like these EPDs that we can. But with that, over 90% of all domestic structural steel is actually tied to a mill-specific EPD. So if you're really looking to hone in and understand the environmental impact of your building, you're able to, because there's one tied directly to a mill. So what this means is you can find this information if you're like, I would love to do this, but I don't know how to find it. Being submitted on a project always, if it's not required to submit EPDs, which is something you can do in your specs, then also you can look at your mill certs that will get submitted as part of the project to your engineer, and basically find out what mill is on there. So product stages of an EPD, again, I understand folks may be a little familiar with this, but we talked a lot through the A1, A3 product stage. And really, when it comes to structural steel, the majority of the environmental impact or embodied carbon is in A1. That's about 85% of the of the embodied carbon of structural steel. So that's why we spent so much time talking about that process, because it's really what's moving the needle on the sustainability of structural steel. Transport is about 8 to 10% of the environmental impact, and manufacturing. So in this instance, that would be the steel fabricator is the rest. There are a couple of decarbonization pledges that are tied to either 2030 for architecture 2030 or 2050 for SE 2050 for the structural kind of engineering equivalent. And a lot of them are to reduce greenhouse gas intensity or become carbon neutral. A couple of things to note from this. A lot of the mills have started to work with their local municipality or state municipality to either run when at off-peak hours. So when electricity would just be going into the ground, the steel mill's running at that time to kind of reduce environmental impact. They're working to explore alternative energy for the general electrical grid. This includes Gerdau partnering with a 174 Power Global to build an 80 megawatt solar field adjacent to its mill. And then finally, there is zero mass scale structural steel available. It is through carbon offsets, however, due to kind of the limitations of the electrical grid at this time. Finally, I think probably the part of the presentation most folks are waiting for: what can you do as a designer to design a more sustainable structural steel building? There's a lot of different things you can do or work with your structural engineer to do. And one that's an easy kind of give me if you're able to do it on your project is have a fabricator involved early on in the process. If they know your sustainability goals, they're able to, and I or AISC can facilitate that. If they know your sustainability goals, they'll be able to kind of work with you on and identify some things that you could change about either your design or your building that might make it a little bit easier to build more sustainably. Some of these things include the lateral system selection, cambering. Again, I understand not everything is in your purview on the call, but sometimes it's things that are worth a discussion. Specs, fire protection, kind of your domestic material, and cambering. And we'll talk about these in a little more depth, which is why I'm just reading them off right now. The first one is cambering. Essentially, AISC has a design guide for this. It's a way, a lot of sustainability strategies are to reduce the amount of steel you use, and this is one of them. So if a beam is controlled by deflection, you can essentially camber it either mechanically or with heat to arc upwards, so that once the full self weight of the building's on it, on the beam, it will kind of lay flat along this line. Another thing to consider is reinforcing steel beams at points of high load, which means that if you don't need a very large steel member for the entire length of a beam, it's worth considering if you just want to reinforce instead of upsizing a beam. And it's not just about like an engineer's decision to do this. There can be some control over where that load is going on the beam that makes it kind of a holistic design team decision. So if it's more feasible to do on one part of the beam than another, because it may not end up being more sustainable if there's more cost, which again is why we encourage talking to a steel fabricator, but it may, and so that's why we include it, because it's worth exploring. Castellated steel beams are another really good strategy, especially you'll see them most commonly used in parking garages and warehouses. Essentially, you're producing a smaller steel beam and then increasing the depth by cutting it, as you see on the screen here. I'm showing circular castellated beams, but there are other shapes as well. And so an example here from Anaheim is the just kind of a use of castellated beam, I think, for look, but it does show a good example of, you can run all utilities through these castellated beams. And so that also helps with the use of coordination, pending what type of building you have. Another thing that I'll just note that's happening with steel is the embracing of high strength steel. This could be 65 KSI up to 80 KSI. High strength steel does not have any more or less environmental impact than just the regular steel you would specify. So it's really a strategy to reduce weight. So a lot of times you'll see this with columns, but a study by the engineer MKA noted that really, if you use high strength steel, whether it's in a 5-story building or a 35-story tower, you're still getting a tonnage savings, which then results in a global warming potential reduction. So it is something to note that even if you think, oh, my building's not a high rise, we don't need to consider this. It is something that will move the needle for you. So something worth looking into if you're even looking at a more mid-rise. Everyone's favorite side on this is the reduction of of transfer beams. Again, this is more just thinking about where is that may be feasible. It may not be, but if there's somewhere that you can even reduce a transfer by a little bit, not even as dramatically as you're seeing on the screen, you are going to see a reduction in tonnage and therefore a more sustainable building. Another thing that AISC has provided is a hybrid steel framed with wood floors design guide. And so this is just a non-proprietary guide. There's both guidance just generally on hybrid systems, and then also design guidance. So there's good information in there for everyone. But the reasons you might use a system, you have a long span beam and you're not really able to make it work with another material. You might want to reduce your column size. It might be an area where there's a high MEP service coordination and it's easier to coordinate a beam opening with structural steel. You might have some vibration performance concerns if there's equipment, and there might be weight concerns as well. So you might get a more lightweight system. So something to look into and something that AISC does support and provide guidance on. And I'm happy to connect you with people if you have questions about that. One of the final numbers, and I've talked about specs a little bit, but AISC has weighed pretty heavily into the SE 2050 metals spec guidance for structural steel. And so that's where there'll be things like language regarding recycled content to ensure you're able to get a beam that's gone through EAF production and take advantage of the EAF supply chain. And obviously what that also means is most of the time you're specifying domestic. At least 90% of all wide flange beams used in the US are produced in the US. And so that just speaks to kind of the benefit and kind of the fact that it's not really going to be a huge change to you by making these changes to your specs. There is more information from AISC that you can find on our website that are including white papers and a quick guide to Buy Clean California steel provisions. I do just like to pull this up because it might be the first time some folks are looking at it, but Buy Clean California for hot rolled sections, hollow structural sections, and plate, which is what falls under AISC and the steel industry's purview, are meeting numbers if with or without. Actually, one thing I should note is that right now we use an industry average for fabrication because there's not enough significant variation. So it is worth looking at what number you're using for that as well. But you can see it's about at that 1 ton per ton, 1 ton of CO2 per ton of steel number that we were looking at earlier with a graph of all of the different steel producing countries. And that's about what we're looking at for the hot rolled sections. If you've started looking into the changes to CalGreen that are happening for the prescriptive method, these numbers are much more, the numbers here on the screen, I should say, are much more stringent. So if you're not necessarily having to react to this yet, but it is important to know. And what I like to tell people is if you know that your project is going to have these sustainability goals, whether it's because it's mandated with Buy Clean, it's in your specs or something else, the sooner you can let the contractor and the fabricator know. They should know, but sometimes it's a miss. So the sooner you can start that dialogue, the easier it will be to just get the reporting and the environmental product declarations at the end of the project. Finally, we also have the Steel Solutions Center. So if there's any kind of questions that ever pop up about structural steel sustainability or otherwise, you're always free to reach out to them or myself, and we'll make sure someone with a lot of encyclopedic steel knowledge is able to answer them. And there's a bit of a sneak peek I included at the end here related to our Fabricator Sustainability Partner Program. So in addition to the work that we've been doing with our industry average EPDs and our work providing guidance to the industry and our legislators, we're also working with education with the fabrication industry. And that's, it's the same reason you're here today for this presentation. It's because there's a lot of changes lately and everyone's trying to get up to date. And so right now we've been launching our sustainability partner program. So eventually, similar to certification, you'll be able to identify steel fabricators, even locally, that are more guaranteed to be more knowledgeable about structural steel because they've gone through this program and they've set up processes in place to ensure they're a good sustainability partner for designers. Finally, our assessment question. I won't I won't make you answer it because I think it's fairly obvious, but what structural building material can be used an infinite number of times without loss of quality? So essentially recycled an infinite number of times, and that would be structural steel. So specifically EAF, the EAF process is what's being referenced here. With that, I'll leave you with kind of my contact information. If you ever have any questions related to a follow-up, you're always welcome to email me. I've worked with kind of the range of folks at this point on their sustainability questions here in California. And I'll also open it up to questions here for folks. I see the chat is starting to pop up.
Hannah, there is a question. Let me see.
Yes.
So let's see. What is the percentage of steel used in U.S. building construction in U.S. produced versus China?
Yes. So I have a number for you for wide flange, which is about 90% is US. But outside of that, I don't actually have that number. It's something I've been trying to find out myself, and Quentin and I can follow up with you after this to get you a better number. It's something I've been actually chasing down this week. But if for wide flange beams, so for the majority of steel, you're going to see it's about 90% domestic market. Well, if there are questions that pop up later, I know it was a lot of information to take in. Feel free to email me again. My email is on the screen. And thank you all for spending your lunch hour learning a little bit about structural steel and sustainability.
Thank you.